Hello Professor, this is Kamajaman from Jangong Kim Labs. Now I am going to make a YouTube video according to the midterm examination question 1, 2, 3. So let's start. There are 4 questions for midterm 1. So I am going to solution one by one. So first question is draw the Fermi direct distribution in intrinsic silicon. There is a value for energy gap 1.1 electric volt at temperature 300 and 400 K. As you can see, there are two tables. This first table for constant value. So I need to use this equation if I want to get the Fermi direct distribution pattern. So according to the question, there is 1.1 electric volt at temperature 300 K and 400 K. So I need to calculate the probability at temperature 300 K and 400 K. So if I use this calculation, you can get the probability very easily. So I just put this equation here on function, then I get this value for probability at 300 K and 400 K. So now I need to find the Fermi direct distribution pattern at temperature 300 K and 400 K. If I select both probability here, then I can find this curve. Just go to the insert and select here, then I get this Fermi direct distribution pattern. So this is the conduction band, this is the valence band. So and this side is energy range, and blue line is for temperature 300 K and yellow line is for temperature 400 K. Now I am going to solve the question number 2 of midterm 1. This question is Fermi level is 0.2 electric volt below conduction band. Draw Fermi direct distribution function in silicon. There is energy gap 1.1 electric volt at temperature 300 and 400 K. So I can draw the Fermi distribution curve same way. So I need to use this equation. I need to just change this value here, then I can find this curve here, and same step is 0.02 electric volt. I need same step, I just change, there is some value. So same way I can find this probability, then I find this Fermi direct distribution curve here. So same way I just select and go insert and go here, then I find this curve, the conduction band, valence band and energy range. And same way we can solve the question number 3. This question number say that Fermi level is 0.2 volt above valence band. Question number 2 was conduction band, this is valence band. So Fermi direct distribution function in silicon, the energy gap is 1.1 electric volt at temperature same. Now I am going to do midterm 2. There is 2 questions. First question is silicon semiconductor is doped with N equal 10 to 16 and 10 to 18. Its n-type dopant. Find Fermi level and calculate the whole concentration at temperature 300 and 400 K. Draw Fermi level, direct distribution draw Fermi-Dirac distribution function at temperature 300 and 400 K. So let's start question number 1. When ND equal 10 to 16, and we can write ND equal N0. We know that N0 and P0 equal intrinsic square. We need to use this equation for this calculation. So we can write P0 equal intrinsic square divided by N0. We know that intrinsic value is 1.5 into 10 to 10. Square, and N0 equal 10 to 16. If I calculate, we can get this value 2.25 into 10 to 4. Now we can calculate Fermi level. This is the P0 means whole concentration. So now I need to define Fermi level. This equation we can use for calculate the Fermi level. Now just put this value here. So this is the Fermi level for N equal 10 to 6. Now when N equal 10 to 18, same way we can calculate this thing. So this is the whole concentration for N equal 10 to 8. Now we need to find the Fermi level for N equal 10 to 18. So if I calculate this, we can can find this value 0.466 electric volt. So this is the question number 1. So now I am going to start question number 2. This question explain what is the difference between the Fermi direct distribution pattern at 300K and 400K. Draw the figure using MATLAB or Excel and draw them separately. And we need to make this use this value and step 0.02 electric volt. This is the question number 2 of midterm 2. Explain what is the difference between the Fermi direct distribution pattern at temperature 300 and 400K. And draw the figure using MATLAB or Excel and draw them separately. So now I am just draw this Fermi distribution using this value. It's not difference between previous question, so I just using this constant value and change this value here, what I get from this math. And the carrier energy range, same way I just making using step 0.02 electric volt, and I find the probability of temperature 300K and 400K, and I got this Fermi distribution curve. Same way, just I select this value and I go the insert and select here, then I find this curve. So this is the actually question number 2 of midterm 2. So you can use this equation for this. So I have already finished midterm 1 and 2. Now I am going to do midterm 3. This is midterm 3. This question is describe what did you learn from lecture 1A to lecture 1G. So I'm just explain what I learned during these classes. First I write here about semiconductor. What is semiconductor? Semiconductor are materials which have a conductivity between conductors and non-conductors. Semiconductor can be pure elements such as silicon or germanium, and compounds such as gallium arsenide or cadmium selenide. So this is the explain of semiconductor, and the material which can be controlled with the concentration of electron or hole. To do that, the energy band gap of the material should have around between 0.17 to 3.5 electric volt. Then origin of energy band gap. Origin of energy band gap is actually in a semiconductor the valence band is completely filled with electrons while the conduction band is empty. The energy gap between the band is less for electrons to jump from the valence band to the conduction band. Room temperature needs to be maintained. Then I learned electron, hole and state. I write here separately, and charge polarity, doping rarely used in semiconductor are pure silicon or germanium. So this is very important thing is doping for semiconductor, and n-doping, p-doping also most important. So I write here separately what I understand about this question, and importance of Fermi direct distribution, physical meaning of Fermi level. This topic is most important. As Professor said, the energy level known as the Fermi level is the one above which the probability of detecting an electron at 0K is 0. In other words, all of the electrons are less energetic than the Fermi level at 0K. So I have finished my midterm 3 question. So now I am going to finish my YouTube video. Thank you.